Okay, for this lesson, we're going to talk about multiplying, dividing, and simplifying radicals. So you can use the product and quotient properties of square roots together with the commutative, associative, and distributive properties to multiply, divide, and simplify square root radicals. So let's look at our first example here. We have 3 square root of 2 times 4 square root of 18. And basically, the rules that we've learned so far tell us that we can multiply the coefficients together and we can multiply the radicals together. Okay, because remember we talked about the rule if I have square root of 2 times the square root of 18, that's the same as the square root of 2 times 18. That allows us to multiply the radicals together. And then we just think of the 3 and the 4 as if they were coefficients, which if they were coefficients with variables, we would just multiply them together. So if we multiply this together, we get 3 times 4, which is 12. And 2 times 18 is 36. So we have 12 square root of 36. Well, the square root of 36 happens to be 6, and 12 times 6 is 72. So 3 square root of 2 times 4 square root of 18 is equal to 72. Okay, if we look at this one, these are two fractions. And again, using this same principle up here, we can do this. We can say this is the same as 3 times 14 over 7 times 27, okay? And I can then simplify the same way I would with regular fractions. I can say, well, the 7 and the 14 share a common factor of 7, so that becomes 1 and that becomes 2. And the 3 and the 27 share a common factor of 3, so that becomes 1 and that becomes 9. So here's what I'm left with. I have 2 times 1 on the top and 1 times 9 on the bottom. I can then separate those out so that it looks like that. And the square root of 2 is just square root of 2. Square root of 9 happens to be 3. Okay, so that's how I can simplify that. I could have even just left it like this and just gone through and simplified. Okay, but I wanted you to see how we spread it out. Okay, you can eliminate the radical from the denominator by multiplying a radical expression by an appropriate value of 1. Okay, so basically what this is saying is that technically we're not allowed to have a radical in the denominator because it's considered to be irrational, and we don't like irrational numbers. So if we end up with a radical in the denominator, there's a process that we go through and it's called rationalizing the denominator. We're making sure that this is rational. And this is the process that we go through. Okay, so here we went through and I had square root of 5 over square root of 7. And basically what we did was we multiplied the top and the bottom by the same number, which happened to be the square root of 7. Watch what happens. If I have the square root of 7 times the square root of 7, that's the square root of 7 squared, which would be square root of 49. Square root of 49 is 7. So multiplying a rational number or a radical number, I'm sorry, a radical number by itself gives you the number that was underneath the radical, okay, if that makes sense. So square root of 7 times square root of 7 is the square root of 49. I've now created a perfect square. Square root of 49 is just 7. Okay, so that's how we get rid of that radical, by creating a perfect square and then just taking the square root. I also have to multiply the top. 5 times 7 is 35. 35 doesn't have any perfect square factors, so we just leave it like this. Okay, so that's rationalizing the denominator. Now here's basically the steps that we would go through. So an expression having a square root radical is in simplest form when no integral radicand has a perfect square factor other than 1. So in other words, I don't have a square root that I can still factor something out. So if I have 32, that's not in simplest form because I can factor out 16, which is a perfect square. Okay, so this would be considered simplest form. There are no fractions under a radical sign, so we got to get rid of any fractions that are under a radical sign, because if I have a fraction under a radical sign, that means my my denominator is irrational. Okay, so here we have fractions under a radical sign, and no radicals are in the denominator. Okay, so it'll make more sense when we go through. So if we look at this one, 3 over square root of 5. It's not simplified because I have a radical in the denominator. So to get rid of that, I'm going to multiply the top and the bottom by square root of 5. Square root of 5 times square root of 5 is the square root of 25, and the square root of 25 is 5. Okay, so I've rationalized the denominator. Here I just have 3 square root of 5. I can't multiply those two together because one is a radical and one is not. So I just leave it like this. We don't care if there's a radical in the numerator. Nobody cares. What we do care about is having a radical in the denominator. Okay, so we have a rational number now in our denominator, so everything's cool. If I look at this one, 7 over 8, the square root, I'm going to multiply this times 8 over 8. Okay, 8 over 8 is just another way of writing 1. But when I multiply this, my denominator is going to become square root of 64, which is equal to 8. Okay, so I've rationalized the denominator. 7 times 8 is 56. And I look at 56 and I say, well, I know it's divisible by 4. Happens to be 4 times 14. So the square root of 4 is 2. So I have 2 square root of 14 over 8. Well, just because this is rationalized doesn't mean I'm done. 2 and 8 have a common factor of 2. So I end up with the square root of 14 all over 4. Okay, so a lot of times there's several steps going through to get to the final simplified fraction. All right, let's look at some more. These are fun. All right, so if I look at this, the 3 and the 24, because they're both under radicals, I can treat them as I would a regular fraction. And 3 over 25, I can simplify. They have a common factor of 3. So I can factor out the 3 here. 24 divided by 3 is 8. So this is the same as 9 over the square root of 8. Okay, I can then simplify this a little bit further. There's 2 ways I could do this. I could do this. I could say, well, this is the same as 4 times 2, so 9 over 2 square root of 2. I could do it that way, but I have a radical in my denominator, so I'd have to multiply everything times square root of 2, so I would have 9 square root of 2 all over 2 times square root of 4. Square root of 4 is 2. 2 times 2 is 4. So that's kind of a long way of doing it. Here's a shorter way of doing it. 9 square root of 3 over square root of 24. I go ahead and I simplify this. So I have 9 over the square root of 8. And then I'm just going to multiply the top and the bottom by the square root of 8. So I have 8 on the bottom, 9 square root of 8. 8 I can then simplify into 4 times 2. So it's kind of the same thing I did here, except now I'm doing it on the top instead of on the bottom. So this is 9 square root of 4 times 2 over 8. Square root of 4 is 2, so I have 9 times 2 over 2, 9 times 2 times square root of 2 over 8, which is 18 square root of 2 over 8, which I can simplify that to 9 square root of 2 over 4. Okay, so again, it takes quite a few steps. If we look at this next one, I have 2 mixed numbers, and we don't do anything with mixed numbers. We have to change them to improper first. So 3 times 7 is 21, plus 3 is 24 over 7. And 2 times 3 is 6, plus 1 is 7 over 3. And these 7s will cancel out. 3 goes into 24 8 times. So what I'm left with is the square root of 8, which we know is 4 times 2. So it's 2 square root of 2. Okay, and after a while, you'll get to the point where certain radicals like this, you'll already know what it should be when it's simplified. Okay, so that's just going through some of the steps that we would use to make sure that our expression is completely simplified. All right, so now we've got things that are a little bit more involved, and we're going to multiply these through. And it says, assume that all variables represent positive real numbers. If they didn't, if we couldn't assume that, then that would change how we represent things. But we're going to just assume that all our variables represent positive numbers. So here's what I do. I'm going to multiply my coefficients. So my coefficients are 3 and -2, so that gives me -6. I'm then going to multiply everything that's under the 2 radicals. So I have a squared, b squared. Okay, well, the square root of a squared is just a, and the square root of b squared is b. Remember that we're saying that a and b are positive, so we don't have to worry about any absolute value symbols. So there is the solution to my first one. Here, I've got 5 minus square root of r within parentheses. I'm going to use the distributive property to multiply by the square root of r. Square root of r times 5 is 5 square root of r. Remember, we can't combine those because this is a radical and this is not. However, these two are both radicals, and so I can multiply those, and that gives me the square root of r squared. The square root of r squared is just r. So I have 5 square root of r minus r. So that's my final answer there. If we look down at our proof, again, I can multiply the numbers on the outside. Those are my coefficients. 5 times 8 is 40. I can multiply the numbers inside the radicals. That's going to give me 63. I then need to see if I can simplify this. 63 can be broken down into 9 times 7. 9 is a perfect square, so I have 40 times 3 square root of 7, which gives me 120 square root of 7. Here I have a fraction, and I want to see if I can simplify these fractions at all. 75 and 18 do not have any common, they don't have any common factors, so I can't simplify them that way. However, I can simplify the radicals themselves. So 75 is the same as 25 times 3. And 18 is the same as 9 times 2. So that's going to give me, the square root of 25 is 5. 5 square root of 3 on the top. On the bottom, square root of 9 is 3. 3 times 2 is 6, so 6 square root of 2. So that looks pretty simplified, except I have this radical in the denominator, which I'm not allowed to have. So I'm going to multiply the top and the bottom by just square root of 2. I don't need to worry about the 6, just the square root of 2. So that's going to give me 5 square root of 6 on top, because square root of 3 times square root of 2 is square root of 6. Here it's going to give me 6 square root of 4. Square root of 4 is 2. So I have 5 square root of 6 over 6 times 2, which is 12. So 5 square root of 6 over 12 is going to be my final answer there. I have a rational number in the denominator. I can't simplify square root of 6 any further. And 5 and 12 have no common factors. Okay, for this last one, I'm going to multiply my coefficients, which are 4 and 3, so that gives me 12. I'm going to multiply my radicals, which gives me a squared and b to the third power. Okay, I'm going to go ahead and break this up again to what we had before, because the square root of a squared is a, the square root of b squared is b, but because I would have had this third b, I can't do anything with it. So this just gives me 12ab times the square root of b. Okay, there's usually going to be a lot of steps involved in each one. Sometimes you can do it in different orders. Start off by multiplying coefficients together and radicals together, and then basically you're going to go through and simplify the radicals until you can't simplify any further.